Hello everyone, I am Dr. Bhaumik. In this video, we will discuss about oxygen hemoglobin dissociation curve. Let's start. We know that oxygen is carried in the blood, in that 97% of it is carried by hemoglobin. When it is carried by hemoglobin, this is known as oxyhemoglobin. This formation of oxyhemoglobin is by the process known as oxygenation and not by the oxidation. What is the difference? When the oxygenation is taking place, whenever there is requirement for oxygen, the oxygen can be easily dissociated from the hemoglobin and the oxygen can go to the tissue which requires it. Now, this saturation of the hemoglobin with oxygen, that is amount of oxyhemoglobin formation, depends on the partial pressure of oxygen. When the oxygen pressure is more, at that point more of the hemoglobin will get associated with oxygen to form oxyhemoglobin, and when the pressure of oxygen is less, this oxyhemoglobin will get dissociated and it will lead to release of oxygen from the hemoglobin. Okay, let's understand this by formation of a curve. This is, let's say, this x-axis which is showing partial pressure of the oxygen, and this y-axis which is showing percentage of hemoglobin saturation. Now we know as the partial pressure of the oxygen increases, there will be increase in the saturation of the hemoglobin by oxygen. Okay, if we are marking a point where this graph has reached, this is the point. Okay, now as further oxygen pressure will increase, more saturation of the hemoglobin will take place, and this is how a curve will further form. And as the partial pressure of the oxygen keep on increasing, the saturation of the hemoglobin can increase up to a point where the saturation is reached. Okay, so this is how a curve will appear if we are plotting it in this manner. This curve is known as oxygen hemoglobin dissociation curve, which shows relationship between, as we saw, partial pressure of the oxygen and saturation percentage of the hemoglobin. And as I told you, the reason the shape of this curve is sigmoid shape. Now let's see what are the factors which affect this oxygen hemoglobin dissociation curve. There are two factors which can affect. First is the factors which increase the acceptance of the oxygen by the hemoglobin, that is more association between oxygen and hemoglobin, and the second is decreased acceptance or more dissociation between the hemoglobin and oxygen. In the cases where the factors increase the acceptance or when there is more association between the oxygen, what happens is, let's say in this example where you are seeing on x-axis, for partial pressure of oxygen x, the percentage of hemoglobin saturation is P. But in presence of the factors which increase the acceptance of the oxygen, for the same pressure of x, the saturation percentage of the hemoglobin will increase. Okay, and as we keep on increasing the partial pressure of the oxygen, the saturation will be more as compared to which was previously, because these factors which we are discussing are causing more association of the oxygen with hemoglobin. So this will keep on increasing, and if we see the curve that forms in the presence of these factors, we can see this curve has shifted to left as compared to it was in the previous condition. Same way, there are factors which causes dissociation of the oxygen from hemoglobin. That is, when here you can see that in the example that on x-axis, in the partial pressure of the oxygen x, the pressure which was P previously, in the presence of these factors which are causing dissociation, this pressure will decrease. That will be at this point. And even if you keep on increasing the oxygen as compared to previous condition, this dissociation or this association will keep on decreasing only. And if we form a curve for this condition, when these factors are present, it will be seen that the curve is shifting to right. So what we can see is, in the presence of more association of the oxygen, the curve is shifting to left. But in case of more dissociation of the oxygen, the curve is shifting to right. Okay, now let's see which are these factors which increase or decrease the association or dissociation of the oxygen from hemoglobin. The factors which causes right shift, that means the factors which causes more dissociation of the oxygen from hemoglobin includes, first is when there is decreased partial pressure of the oxygen, when there is increase in the pressure of carbon dioxide. This is known as Bohr effect, which we are going to discuss next. And increase in the acidity in case of, or increases acidity or decreased in pH. Both of them are causing right shift. Why will they cause it? That also we'll see next. Increase in the body temperature and increase in 2,3-DPG, that is diphosphoglycerate, which is a metabolic product which increases in case of exercise, high altitude, anemia, alkalosis, in presence of inosine, pyruvate or phosphate, or in presence of hormones like thyroid, growth hormone, androgens, or in case of hypoxia. In all of these conditions, hemoglobin will release oxygen, because in all of these conditions our body will require more of the oxygen. Okay, these are the factors which are causing right shift. Whereas the factors such as fetal blood, now fetal blood has hemoglobin which are different from our adult hemoglobin, that is known as fetal hemoglobin. This fetal hemoglobin have more affinity for oxygen. So if oxygen affinity is more, obviously the blood will, or the oxygen will enter the hemoglobin and the curve will shift to the left. Same way the factors reverse to the ones that are causing right shift, that is when there is increased alkalinity, when there is decreased temperature, and when there is decreased DPG, the curve will shift to left. Now for exam purpose, you can remember broadly 4 factors: C, A, D and T. C stands for carbon dioxide, A stands for acidity, D stands for 2,3-DPG and T stands for temperature. Now when all these 4 factors, when they are decreasing, when carbon dioxide pressure decreases, when the S or the A here you should remember as pH. Okay, so when the, so okay, let's keep it as acidity over here only. The C is carbon dioxide when it decreases, when the acidity decreases, when the DPG decreases and temperature decreases. In all those cases the curve is shifting to left. Whereas when these 4 factors are increasing, it will cause the curve to shift on the right side. Only one factor you should remember separately is fetal hemoglobin, which is also causing the shift to turn on the left side. Okay, next let's see Bohr's effect. So what happens is, in our tissue during metabolism, the presence of carbon dioxide will increase and oxygen will decrease. And because the carbon dioxide is more in tissue, with help of osmosis, this carbon dioxide will enter the blood. Now in blood there is presence of water as well, which will mix with carbon dioxide to form H2CO3, which we know is carbonic acid. Now this carbonic acid will increase the acidity, and we know when the acidity increases, the curve shifts on the right side, and when the curve shifts on the right side, there will be dissociation of the oxygen from hemoglobin. So this oxygen which is dissociated from the blood will enter the tissue, which will provide for the lack of the oxygen that was there. This process is known as Bohr effect, which shows that increase in the carbon dioxide pressure and increase in the acidity, there will be dissociation of the oxygen from the oxyhemoglobin. What is double Bohr effect? The double Bohr effect you see in the fetus. Here what happens is that the carbon dioxide from the fetal side, this is the fetal side and this is the mother side. Okay, so this carbon dioxide from the fetal side will diffuse into the maternal blood. This is the normal Bohr effect that we already seen, right? So it will cause increase in the maternal hydrogen ion, so it will cause increased acidity. So ultimately more of the oxygen will be dissociated and it will be sent to the fetus. In addition to that, because this fetal blood is losing carbon dioxide, it will become more alkaline, and because it is becoming more alkaline, the hemoglobin will accept more of the oxygen. So again more oxygen is taken by the fetal blood. So the Bohr effect is happening on this side also as well as this side as well. So this phenomenon is known as double Bohr effect. Okay, that's all from this video. If you have any doubts, feel free to post in the comment section. All the best. Thanks for watching the video. Don't forget to subscribe to our channel for more updates.